So in this lecture, I am going to explain you about limiting reinforcement index. So first from IS 456 2000, so that is from annexure G. So page number 96, we have a formula to find the depth of neutral axis. So here this is the formula. So depth of neutral axis can be found by xu by d equals 0.87 Fi AST divided by 0.36 FCK BD. So I will copy the same equation. So depth of neutral axis. So formula will be xu divided by d equals 0.87 Fy AST divided by 0.36 FCK BD. So I will call this as equation number 1. So next I will rearrange the terms and I will simplify the same equation. So next it will be rearranging the terms and simplifying. So just I will cross multiply. So it will be xu multiplied by 0.36 FCK BD, which is equal to D into 0.87 Fy AST. So this can also be written as AST divided by PD equals 0.36 FCK XU divided by 0.87 FYD. So next I will simplify 0.36 divided by 0.87. So 0.36 divided by 0.87. So it will be 0.413. So AST divided by BD equals, so it will be 0.414. So FCK XU Fy into D. So this is my second equation. So next we know the formula for percentage of steel. So that is PT equals AST divided by BD multiplied by 100. Okay. So this can be written as AST divided by BD, which is equal to PT divided by 100. So I will call this as equation number 3. So equation 3 is nothing but it is the equation for percentage of steel. Next I will compare equation 2 and 3. So next it will be comparing equation 2 and 3. So equation 3 is Pt divided by 100, which is equal to, so your equation 2 will be 0.414 FCK XU divided by Fy into D. So next it can be further simplified as, so Pt Fy D, which is equal to 100 multiplied by 0.414 FCK XU. So Pt Fy D, which is equal to, so 100 multiplied by 0.414, so it will be 41.4 FCK XU. So this is equation number 4. Next, so I will rewrite this equation 4 for limiting moment. So we know that at the limiting moment the section is balanced with Pt equals Pt limiting and XU equals XU max. So and XU equals XU max. This is at limiting moment. Because ensuring that both steel and concrete reach their respective limits of performance simultaneously. So at limiting moment, we assume like this: Pt equals Pt limiting, Xu equals Xu max. So I will substitute these in equation number 4. So your Pt will becomes Pt limiting Fy D, which is equal to 41.4 FCK. So XU can be written as XU max. So I have rewritten the equation 4 by substituting Pt as Pt limiting and Xu as Xu max. So let me rewrite it again. So Pt limiting multiplied by Fy, so divided by FCK equals, so the remaining terms will be 41.4 XU max divided by D. So this is equation number 5. So here in equation number 5, the constant Pt limit Fy divided by Fck is known as limiting reinforcement index. So in this equation 5, this constant is known as limiting reinforcement index. So this is the equation for limiting reinforcement index. So let me calculate the limiting reinforcement index for various grades of steel. So from IS 456 2000, so page number 70, we have XU max by D values for corresponding grades of steel. So for FY, here 250, 415, 500, 550. So XU max by D values. So for 250, it is 0.53. So for 415, it is 0.48. For 500, it is 0.46. For 550, it is 0.44. So I will substitute these XU max D values in equation number 5. So we will get limiting reinforcement index for various grades of steel. So let me write the equation number 5. So equation number 5 is so PT limiting Fy divided by FCK, which is equal to 41.4 XU max divided by D. So this is your equation number 5. So in this equation, in case of XU max by D, I am substituting the above values. So first, so when Fy is 250 for mild steel, so equation will be PT limiting percentage of steel Fy divided by FCK, which is equal to 41.4. So for Fy 250, so XU max by D value will be 0.53. So let me solve this. 41.4 multiplied by 0.53. So it is 21.94. So this is the equation for 250 grade steel. So PT limit Fy divided by FCK equals 21.94. Similarly, calculate for various grades of steel. So for 415, 500 and 550. Here your left hand side will be same. PT limit Fy divided by FCK, which is equal to for Fe 415, so 41.4 multiplied by 0.48. Next for 500 grade steel, it is 41.4 multiplied by 0.46. For 550, 41.4 multiplied by 0.44. So let me calculate it. So 41.4 multiplied by 0.48, which is 19.87. So next for 500, 41.4 multiplied by 0.46, it is 19.04. So next for 550, 41.4 multiplied by 0.44. So it is 18.21. So this way you can calculate the limiting reinforcement index for various grades of steel. So here this ratio is called as limiting reinforcement index. For Fi 250, so it will be 21.94. For 415, 19.87. For 500, 19.04. For 550, 18.21. So similarly, in one of my lecture, I have uploaded a video on limiting reinforcement index. So please visit that video also.